Hello everyone, my name is Indrajit and today I will explain my project, uh, ML project, which is Email Campaign Effectiveness Prediction. So let's begin. So guys, this is my project. Okay, so this is my GitHub repository and I attach the link in the description. So to check my repository file through this link. Okay, so first of all, this is my course project. And this is the given data set. Okay, so this is data email campaign CSV. So this is the data set, and this is my project I did in my course. So this is the project. In this project, the problem statement is this is a email model classification, supervised learning classification model. And in this project, the problem to predict some emails, okay, the by the help of feature of this email. The email would be ignored by the customer, read by the customer, or acknowledged by the customer. This is the three outputs we can get. Okay, so for the business, we have to send email to the customer, but sometimes it's work, sometimes it's valuable, but sometimes it's not valuable. So that's the reason why this project I did. Okay, so this is the GitHub link, and here uh, start with the important necessary libraries for this project. Okay, and this is a data set. I did this project in Google Colab, so that's the reason why I add the google.colab, okay, from type. So this is at this is this is this code for the link Google Colab or the notebook to the drive. Okay, and after that I import this CSV file data email campaign.csv from this from drive. Okay, so this is the first view, the data set, and I did each and everything. So we can see the row total number of and total number of columns. Okay, 12 columns means the one is dependent variable and other 11 is input variable or independent variable, we can say. So this is the duplicate, zero duplicates. Some columns have null values, and here you can see that the customer location has most null. So this is the visualization of the null values, and this is my whole project. I did everything. This is the unique uh, values for columns or picture, we can say, and everything here. Okay, so there is 80% email status. This is the output variable, or we can say the dependent variable. So 80% emails are ignored. The output is zero, means one mean read by the customer and two mean the acknowledged by the customer, which is very only 0.47%. We can say 3.5% emails are acknowledged by the customer, which is very less. Okay, and here my visualization part. This is the visualization of the ignored, read, or acknowledged emails. Here the distribution of subject hotness score. There is a feature. After that, total past communication visualization distribution, word count. This is total links and so on. Okay, this is some categorical variable. Okay, so here we can say this is the email type. This is first type and second type, 1 and 2 values are there. Here, this is a interesting visualization because here we found a new thing which is email companion type 3. Okay, so email companion type 3 is the most effective, I can say, because here you can see the green part is acknowledged by the customer is highest in this email companion type 3. Okay, so this is we can say, and uh, this is very less, 1 and 2. Here the ignored emails is uh, very high. So email companion type 3 is most effective companion. Okay, so this is some visualization. Okay, after that, the model building part, here we can say this is the customer location. G is the highest location. This is there is a type, and I built a application for this, and in this data set there is some location type only A, B, C, D. Randomly, they not randomly, they just put any value A, B, C, D, but I change with some interesting location for the application. And here, the handling the out. Here you can see that the subject hotness scored some outlier, but our total past communication do not have any outlier. After that, total links have some outliers, total images some outliers, and after removing all outlier, not removing, we use a capping method, and after this method, we can see that there is no outlier in this columns. Okay, and this is some data scaling, categorical encoding. Okay, so customer location, we encode this. After that, data scaling, we use standardized standard scaler. And after that, data splitting. Okay, so x and y split, this is, and after that, x train, y train, x test, sorry, x train, y, x test, y test. Okay, after that, we our data set very much imbalanced. That's the reason why we have to balance this data set. So we use Smooth for this. Okay, after using Smooth, there our data set is balanced. Okay, so this is the model building part, and this is I create two for the matrices. Okay, so this is some accuracy score, precision, recall. We have to calculate each and everything for every model. So I decide, let's create a function for this. Okay, so first of all, I take logistic regression, and here accuracy is very less, which is 54% only. And after cross validation, the accuracy is not improved, 54%. After that, I take decision tree. Here accuracy is not bad, uh, around 70%, 69.47. And after hyperparameter tuning and cross validation, here is we can see some improvement, which is 72% accuracy. And this is our robust model, which is XGBoost. Here we can see the accuracy is 80%. Okay, so I did cross validation and hyperparameter tuning, with the XGBoost, and here accuracy is little bit increase, which is 80%. Here, not this is the 79.6%, which is around 80%. But here we can see that totally 80%. Okay, so little bit increase, and this is some conclusion. So this is my project for the course, and after that I did it 2 months ago. But after that I decided, let's create a new application for this project. So I create application for this project. So this is the file in this repository I added, and this file, this application.ipynb, in this file I create the application, not application, I import the pickle file for the application. Okay, so I did the same. I don't use that IP file. Okay, so I create a new file and I did everything. I don't use the visualization part, the same thing. Okay, so here this is the CT, means column transform. Here one hot encoding standard scalar, and I use mode. Okay, and the same function I created here, and this is the XGBoost with hyper parameter tuning. The same here I take the same values, and everything is same. And here we got the 80% accuracy, almost same. Okay, so and at the last point we imported the ct.pickle, means column format. I take this ct. Okay, I this is the ct.pickle file. Okay, here. Okay, so and after that we take gc XGBoost, means this. Okay, this so no, this is KitSat CB XGBoost model. Okay, I take these two things. This is the ct.pickle and model.pickle. Here we take gc XGBoost model name with the model.pickle. Okay, so this is two new file we get for the application. After that, for testing our model, what I did, just for test, we test this pickle file. For this I import pickle and some accuracy score, this type of things, and here I import this pickle file, I call this and model. Okay, and we store it in city, column transformer in city, and model, which is gc XGBoost in model variable. And after that, what I did, I create a new data. Okay, a new row. This is the row you can see here. Just randomly I take this data, and after that, this is column transformer I use on this data, on this data. Okay, not this is the only a row. And after that, what I did, I predict the value, and it give me 0, means it's what, not give me something like that. But I face so many difficulties for building this project, so many errors, and after that finally I did it. So after that, this is the pickle file for import this pickle, And after that, web application file here, this is the main file app.py. Here I create the app. Okay, this is the code. I use Streamlit for making this application. This is this web application. I will show you the application. And this is the pickle, same model.pickle and ct.pickle, column transformer and XGBoost model. And the remaining some files are not for this project. These files are for the deployment. Uh, this project, it was server. Okay. So this is my whole project I did, and I now the application. So in this repository here, deployed application URL. So this is the URL for this application. Okay. So if we click on it, and here we can see this is the application. Here all the input variables are there. Okay. Email campaign and effectiveness prediction. Okay. So email type dataset, I guess 1, 2, and 3, but I sorry 1 and 2, and I change with marketing and important updates because this is the data dictionary. I take it from the data dictionary, and email send time I take it from the data dictionary, morning, evening, and night. Email campaign type, this is the three type. There are three type the email campaign, type 1, type 2, and type 3. I just decide that the type 2 and type 3 is the, so I didn't check. Email source type, this is the two types, sales and marketing and important admin. So this is I take from the data dictionary. And here the customer location, for making this project interesting, I change, I take it from by my own. Okay, this is not from the data dictionary. Just for making this project interesting, I use some famous and big cities of India: Bangalore, Hyderabad, Jaipur, Kolkata, Mumbai, New Delhi, Pune. Okay, and this is the subject hotness score. We take any value between 0 to 5, and after that, total past communication. We have to give some number for this. Okay, so I can show you how it works. This is winning. This is let's type 3, and it's it's Kolkata, not sales and important admin. Total past communication is 2, and total words 800. Okay, let's suppose it is 800. Total links is 1, and total image is 0. There, here we can see this is a button. If we click button, and it show the email is could be ignored. Okay, and the chances of ignored is 83%. This is huge. And how this web application help us, if we send any message to customer, we can check by the help of the features of the email. The email would be ignored or read or acknowledged by the customer. So the this type of help, this web application can help to the client. Okay, so this is, and if we change, uh, 1000, total past communication is, let's suppose, 40, total links is 5, total images we can say the 5, and this is a change with Jaipur, and this is the morning. Okay, if we predict this, okay, ignore the, but for the chances is 44%, which is less. So this help us for the this show us the probability, so it's help us very much, I guess. That's why I added this probability. If we change with evening, type 2 and marketing, if we predict. Okay, ignored, but the ignored probability is 62%. Marketing and change updates. Okay, ignored, but the 77%. But it shows us another value, but I don't know why ignored, but the 64%. Okay, so it shows us the different value which is read. Email would be read, and the probability of read is 45%. So this is our model, and this is my whole project I did. This is the web application. I am very happy to share this model with you guys, and this is my whole project. I learned so many things by making this project, and it's take so many time. So that's the reason. Okay, thank you so much.